Hello and welcome to the video journey of daily challenges. Let's begin our day. Question 20. Okay. Question 2359. Find closest node to given two nodes. Find closest node to given two nodes. You are given a directed graph of n nodes numbered from 0 to n minus 1. Where each node has at most one outgoing edge. The graph is represented with given 0 indexed array edges with size n, indicating that there is a directed edge from node I to the node edges I. If there is no outgoing edges from I, then the edge of I is equal to -1. So, okay. You're also given two integers, node 1 and node 2. Return the index of the node that can be reached from both node 1 and node 2, such that the maximum between distance from node 1 to that node, from 2 to that node, is minimized. If there is multiple answers, return the node with the smallest index. If there's no possible answer, return -1. Okay. It also may contain cycles. Okay, one more time reading the condition, or what I have to return. Return the index of the node that can be reached from both node 1 and node 2. An index of the node that can be reached from both node 1 and node 2. If I'm giving node 0 and 1, return node 2 or node 3, such that the maximum between the distance from node 1 to that node, and the maximum is referring to like the max function, where you can say max of 1 and 2, except that this will be distance from node 1 to that node, and this will be distance from node 2 to that node. So this is a function, this is a condition that's going to be playing a big role. If there's to the node, okay. Between the distance from node 1 to that node and from node 2 to that node is minimized, such as the maximum. So this has to be the minimum. So if the max of this is smaller than some min value, then do something. Just roughly drawing it out doesn't actually mean max, then actually do something. Okay, let's look at some examples. 2, 2, 3, -1. 0, 2, 1, 2, 3, -1, node 0, node 1. Okay, perfect example. Explanation: the distance from node 0 to node 2 is 1. The distance from node 1 to node 2 is also 1. The maximum of those two distances is 1, okay, because they're the same. It can be proven that we cannot get node with a smaller maximum distance than 1. It can be proven that. So we return the node 2. So 3 here doesn't work because the max, 3 doesn't work. Why? Because the maximum between the distance is minimized. The maximum between. So if this had another node here, 4, and 4 was pointing to 2, and this was pointing to 3, it would still be 2. Okay, so I'm wondering if we can just have a, if we can just traverse the whole tree from both of the starting nodes, and then keep track of how many steps it takes to or what is the distance between the starting node and the node to which I'm going, and then run this function here to compute that, to find the minimum distance, the minimum maximum distance. Okay, what if I have distance, what is it going to be? Distance array. Distance says 1. It's going to be equal to -1. -1 is the default value for something that hasn't been visited, of length edges. Let's do, sorry, n edges. We have n and distances 2, and then we say, so these are our two distance arrays, and let's have a function traverse that actually takes in a node and the distance array, and then populates this distance array with the distance from the node. So first of all, distance node is equal to 0. Distance is equal to 0. Okay, while, let's see, while I'm not a leaf, while I am not a leaf node, correct? A leaf node, and confused. While I'm not a leaf node and have not been visited. So how would I do that? While that, I'm going to, just temporary, I'm going to say that my distance has increased by 1, set distance of the node. Sorry, no. I am, okay. While my parent is not a parent exists, and my parent has, or no, sorry, child, my child has not been visited, and this would be implemented as such. Edges node does not equal -1, and distance edges node equals -1. So while my child exists, I'm going to say that I am that child. Node equals edges node. Oh boy. I'm going to now say distance plus equals 1, and distance of my node is equal to distance. Awesome. Now I'm going to populate these two arrays with my node 1 and node 2. I'm going to say traverse node 1 distances, and the same thing for node 2 distances. Okay. Print distances. Let's see what this. Okay. I want to see the nodes as well. Node 1, node 2. Node 1 is 0, so I'm at, it takes me 0 distance to get here. -1, I'm never visiting 1. It takes me 1 to visit 2. It takes me 2 to visit 3. Here, this is for node 1. I never visit node 0. Takes me 0 to visit myself. Takes me 1 to visit 2. And 2 to visit 3. Awesome. So now that I have this, I can just go ahead and say for I in range n. So for all of my nodes, I want to find the is there some n? Trying to find the max distance is int of infinity, I believe. Sorry, disregard that. So for every node, I need to find first the distance for my first I, and the same thing for distance 2. For 1, distance for 1, distance for 2, distance for 1, distance for 2, and now my condition. If max of distance to distance for 2 is smaller than min distance, then I'm going to say I have to return that node, right? And if it's smaller than min distance, I have smaller than min distance, I have a I have to keep track of this node, and this node is just going to be I, so the node that I care about is going to be I. So let me initialize this to be like -1, a non-existent node, and min distance is going to be int of infinity. Believe that's the way to initialize an int of infinity. Actually, let me check that. Print while I'm checking this, I'm thinking of how was it float that I know? And can I just set it to the biggest possible number? Ten to the power of 5 plus 1. Is that gonna... Okay, that's good enough. Min distance. If there's loops, would that be right? Anyway, don't know. So, okay, how am I going to also keep track of min distance, right? Min distance, I have to, has to be, the maximum has to be the smallest. So max dist is equal to max dist. Max dist distance is equal to max distance, right? Because I have to find the smallest. So why? Let's see. I find the maximum out of the two, and why did I set this? No, I'm setting this too much. Return the index of the node that can be reached from both node 1 and node 2, such the maximum between the distance from node 1 is minimized. Okay, so if my max distance is smaller than the min distance, yeah, this is I was just confused. My minimum distance is set to the maximum possible number. Then I'm assuring myself that the max distance between distance 1 between from any node, from node 1 to the current node, distance 1, I'm finding the max between those two, and I'm making sure that this max is going to be the smallest via this, right? Return node. Okay. Okay, already something wrong. Node 1 is 0. I'm outputting 0 as if 0 is the node from which as if 0 is the node to which I can't even reach I cannot reach 0, so it cannot be 0. Somewhere in here, something about this is executing in such a way that it's even allowing here to go. So let me print the max dist and see if I can catch something that's max dist 0, 0, the max. How can the max for 0 be 0, you may ask? And I wouldn't know. how can the, so for node 0, the max is 0. I don't understand. Is there anything, can I run this? Okay, case 2, case 1. Max is 0. Max is 0 with what? What is, okay. If the max is 0, and this doesn't make sense to me, why not just print distance from 1 and distance from 2? And print the max distance, which is here. Between 0 and -1, the max is 0. That is correct. But -1 means that 0 is unreachable. So if 0 is unreachable from 0, then this should never be executed for it. So I can say that, let me just, if the node I'm exploring can be reached from both node 1 and node 2, if the node can be reached from both node 1 and node 2, and the max distance and the max between distances from node and from node 1 and node 2, that node is less than global min. Global min. Let's call it global min. Okay, then I update my global min with the max, set node, and return the node. So if and I need my distance to be greater than 0 and distance 2 greater or equal to 0. Okay. Nice. Okay. Okay, let's take a short second. I think here the most confusing part for me was figuring out how to, okay, I still have those prints in. Was figuring out what that condition was. The maximum between the distance from node 1 to that node to and the node 2 to that node is minimal. Maybe the phrasing is just wrong, or it's not wrong, but confusing. But besides that, I think it's pretty straightforward. Can I spend a couple of seconds trying to do the same, very similar? Okay, same idea. Distance just implemented a bit weird, or a bit different. They have a distances array from 1 and from 2, a DFS, which, yes, I believe it's yes, it is a DFS. We could have called traverse DFS. It's just a very linear DFS. Then let's see, if node is equal to -1, meaning that it's not visited. or node is in visited, then return. If the current node. Okay. And then it so instead of an iterative, they did a recursion, which is fine. Iterative recursion, so they populate this distance from 1, distance from 2, and then they say the same thing here. Min distance is equal to the length of edges. Could have done that also. And for node and range, yes, distance for, this is exactly what we had, if D1. However, it is almost, yeah, it's a lot faster. So, okay, so I don't know if the solution that we had is any worse than this besides the time difference, but wait, is this me? This is not my solution. Anyway, okay. Oh, that was mine beat 30. This one beats a lot more. Okay. Thanks for watching. Catch you next time.